In the previous video, I said that most of the time sequences have a pattern or a set of instructions that come along with them for generating the sequence. And the reason I say most of the time is because it is not always going to be the case. So let's talk for a second about the difference between sets of numbers versus a sequence of numbers. So let's say I was given a set of numbers and I was told that the numbers in this set are -5, 7, 13, 8, -3, 23, and then another 8. So if all I am told is that this is a set of numbers, then there really is no relationship between these numbers other than they are all in the set. So if I want to move these numbers around, for example, I can do that. I usually prefer to do that because I like arranging my numbers in ascending order. So if I wanted to arrange this set of numbers as -5, -3, 7, 8, then the other 8, then 13, then 23, I could do that and there'd be no problem with doing that. Now let's say though, if I were told that I have a sequence of numbers, and let's say the sequence is the same set of numbers that I was given before. So my sequence is -5, 7, 13, 8, -3, 23, and 8. So now that I'm told this set of numbers is also a sequence of numbers, now my numbers are connected. So even though it might seem like this is just a random set of numbers and there really is no pattern to these sets of numbers, I just came up with them off the top of my head. If they tell you this is a sequence, they are telling you this is the order of the numbers. They are given in sequential order, and so I cannot rearrange them. -5 is the first number in the sequence. 7 is the second number in the sequence. 13 is the third number in the sequence, and so on. And so I cannot put 23 is the sixth number in the sequence, and this second 8 is the final number. So I cannot put this 23 in the last spot in the sequence. All of my numbers are fixed in place, and I have to keep them that way because they tell me it is a sequence. So a sequence is really just a set of numbers that has a given order to them. And so the reason I mention this is because even though most of the sequences that you will see they will give you some sort of pattern that you have to decode, is not necessarily true. They can just flat out give you a sequence such as this that is seemingly random, and then you have to know if it's a sequence, these numbers are fixed in place. A sequence is just a set of numbers presented in a certain order. So now let's do a problem where they do give you the pattern. This problem says sequence A is defined by A sub n is equal to 2 times A sub n minus 1 plus 3 for all positive integer values of n greater than 1. What is the value of A sub 1? And so the first thing you might notice about sequences versus just regular algebra is this subscript notation. And so if this is unfamiliar to you, this is one thing to get acquainted with when it comes to interpreting sequences. This subscript has nothing to do with the value of A itself. All this subscript is doing is it is telling you referencing this number's place in the sequence. And so A sub 1 is the first term in the sequence, and A sub n is used to represent any number in the sequence. It's a placeholder. And so if we were to interpret what this equation here is telling us and translate it into just normal algebra, it is saying any number in the sequence, so A sub n, so n can be any number, is equal to 2 times the number before, that's what the n minus 1 means, plus 3. So again, any number in the sequence is equal to 2 times the number before it plus 3. And then they have to say for all values of n greater than 1, because the first number in the sequence does not have any number that comes before it. So now it says, what is the value of a sub 1? So we were just looking for the first term in our sequence. And so now it might seem like without any values for any of the terms in our sequence, there's not much to do other than look at our statements. But I would say one thing we can do is if you just want to sort of write out generically what the first few terms of your sequence would look like, that is worth doing, because it is hard to do algebra when you have these subscripts in the way. So if I just want to sort of translate my terms just into regular variables, then maybe I'll write out the first 3 terms of my sequence. And so I'll say the first term is x. What would the second term be? It would be 2x plus 3. And then the third term, though, is going to be twice the second term plus 3. So it's going to be 2 times 2x plus 3 plus 3. This gives us 4x plus 9. And so on and so on. So if I translate my sequence this way, now my question is sort of, instead of looking for a sub 1, I'm just looking for x. So now I would say let's look at the first statement. Statement 1 says a sub 5 minus 4 times a sub 3 is equal to 9. So let's translate this. It's saying the fifth term in our sequence minus 4 times the third term in our sequence is equal to 9. And so we wrote out the first 3 terms in our sequence before, so we got a bit of a head start. Now let's just go up to the 5th term. And the reason I want to write my sequence out up here as opposed to next to my first statement is because this comes from the prompt, right? So the sequence I'm writing out here, the sort of generic sequence I'm writing out, can be applied to both statements. It's universal. So if this is my third term, my fourth term should be 2 times this plus 3. So that's 2 times 4x plus 9 plus 3, which is 8x plus 21. And then my fifth term should be 2 times my fourth term plus 3. What is this? 16x plus 45. So now I can use this to translate this first statement into normal algebra. So it's saying the fifth term in my sequence, so that's 16x plus 45, minus 4 times the third term in our sequence, so that's 4x plus 9, is equal to 9. And my question, remember, is just what is x? That is the first term in the sequence. And so now here, it might look like I have one equation and one variable. Therefore, I should be able to solve for x, and that makes this sufficient. But I would say you just it's worth checking just to make sure there's nothing fishy going on here and actually solving for x. And usually this is just in terms of GMAT strategy, because I know you don't have to solve for the actual answer in data sufficiency, but usually when it would not take that much time to do so, and if I'm doing good on time, then I usually do solve it, because usually you can use that as confirmation of whether or not you did something right. And also sometimes weird exceptions come up. So let's actually solve for x here. So we got 16x plus 45 minus 16x minus 4 times 9, which is 36, is equal to 9. So look what happens here. My x goes away, which doesn't simplify anything. We don't want to lose our x, and here just canceled out. So we're left with just 45 minus 36 is equal to 9, which is basically just saying 9 is equal to 9. So is this sufficient or insufficient? This is actually insufficient, because what is this telling you? When you get something like this, 9 is equal to 9, it's telling you no matter what number I have for x, no matter what number starts off my sequence, this will always be true. The fifth term in my sequence, even though the fifth term can be a bunch of different things, and the third term could be a bunch of different things, the fifth term minus 4 times the third term is always going to be equal to 9. And therefore, this does not help us. This statement does not help us at all. Tell us what our first term is, because it will be true for any number we choose as our first term. And so this is insufficient. We can actually eliminate C here as well, because this is an example of a case where our statement is not only insufficient, it is irrelevant. It is information that is always going to be true. It's information we knew from the prompt. So our second statement now says the fifth term in our sequence, so a sub 5 is equal to 5 times a sub 3 minus 4. So the fifth term in our sequence is equal to 5 times the third term in our sequence minus 4. And so now, because we already have our sequence written out up until the fifth term, that should be equal to 5 times the third term minus 4. And so let's see if this is also going to lead us to a trick answer. So 16x plus 45 is equal to, which is just 5 times 4x plus 5. And multiply this out. 16x plus 45 is equal to 20x plus 25. And so subtract 16x from each side, subtract 25 from each side. 20 is equal to 4x. Here, we do get a number, 4x, the first term in our sequence. And so this guy here ended up being this, sufficient. This will only be true when the first term in our sequence is equal to 5, which is what makes it sufficient. So take a note of something, and this is one reason why I think sequences are not as complicated as people think, especially on data sufficiency questions. Even though we only wrote out the first 5 terms in our sequence, you can probably tell from this pattern that every single term in our sequence can be put in terms of x. And so they could have been asking for the millionth term in our sequence, and I should be able to say, well, if I can find the first term in my sequence, I can generate all the other ones. And therefore, even if it would be too hard to actually calculate what that millionth term is, as long as I could just calculate the first one, I know it would be sufficient that I could find it. And so that is one reason I like sequences, and that is why it's so important to translate your sequences accurately. So let's do some more sequence questions.